right? The third one that we need to discuss, let's write down, is Macintosh operating system, right? Macintosh, or we say Mac OS, right? Macintosh operating system or Mac OS. We normally say Mac OS, MACOS, Macintosh. The newest version is we call Mac OS, right? Usually we will use for Mac operating systems. We'll also call Macintosh. Macintosh operating system. Now, when you look at Macintosh, there are different versions as well. They also have different versions they have developed. They're developed by Apple computers. The next one, we can write down Google's Android operating system. By Google. So this is we known as mobile operating system. So that is Android. Okay. Right. Right, now let's look at how operating system evolved from the beginning. So in this part, we are going to look at how computers were developed, right? So there were several things we need to discuss when we talk about, operating system. So let's write down the new topic under this: evolution of operating systems. Now, evolution means how we had operating system in early days. So first of all, there was no operating systems in the beginning. Initially, we didn't have operating system, right? So during 1940s, right, we had no operating system. So this is during early, right? Usually we say, right, late 1940s to mid 1950s, right? So that means beginning we didn't have an operating system. Right? And then what happens after that? We had what we call operating system batch oriented. I will explain what this is. We had simple batch system. Then multi-program batch system. These are like different types of operating system we had. And what we have right now is time sharing system. Right? So we didn't have an operating system between 1940s to 50s. Then we had what we call batch system, right? When we say batch system, what happens? You have a set of batches, like we have a set of programs. We put it as kind of a batch, and then when we execute, right? So that's why we said batch processing sequence. Then we have, multi-program batch system. So when there we can run multiple programs. And right now, we have what we call time share. You share the time among different programs. That means nowadays, what happens when you have like different processors, like let's say you are running multiple programs, they share the time, right? We call time sharing. පුතා ලියාගෙන ඉවර නම් කියන්න මට. So we can say so if we write down the times for second generation, usually we talk about right. Thanks. Okay, we can put some times as well. The 1940s to 1950s. So this is sometimes called the first generation, and this is known as second generation and so on. So this is during 1955 to 1965. And then this is around like 1965 to 1980. And now what we have is time sharing. We have 1982, let's say present day, right? That's how these were developed. Right. Now let's discuss in detail how the things were evolved. So let's look at the features, right? We'll start with no operating system. So that's what we have. So we call no operating system. So what happens here? Now those days, in early days, right? Early days, there's no software like in the beginning. So no operating system when computers are developed in the beginning, there was no operating systems, right? When the first computer was developed, there was no operating system. So there was no operating system. Right? The input was punch cards. Right? So if you are not seeing a punch card, so punch card is like this. Right? So punch card meaning like you have a, you don't have to draw this, but this is just to show you like how it look like, right? So early days, there was no operating system. Input was a punch card like this. So all the commands we put into using these, punch cards. And then the output, now this is the input. The output was bulbs. ENIAC, for example, if you remember, we discussed ENIAC. And the output was, bulbs or printouts. Right? So, for example, ENIAC, we had, something like this. You have a set of bulbs to indicate the output. There was no monitor as such early days. Right? This is how things were evolved. No operating systems. So what happened? Right? The human has to involve this. So people has to, use of this. Right? So humans were there to schedule, right? I told you like scheduling means now when you want to run a program, somebody has to, right? Somebody has to enter this. To schedule jobs. And supervise resources, human. were involved. So the problem with the human is they easily make mistakes, right? When there are errors, they have to check registers, meaning memory, right? So when they want to schedule jobs or supervise resources, meaning like printing, even the outputs in bulbs, right? Or power. So everything has to be, somebody has to involve in, managing this. And then when there are errors, they have to check the register details. Right. So if you look at some of the characteristics, right, of operating systems, we can write down we can highlight main things, right, about the so some characteristics of this we need to write down. Yeah. So one, it's serial processing. Serial processing means when you have programs were processed one after the other. It was a single user system. Single user system. Only one person can use the computer at a time. පුතාලි ඉවරම් කියන්න. Right. The next one is users and or programmers directly interact with hardware. Now, early days, hardware means they are very big computers, right? But people were directly involved. People directly involved in, work with the computers. Wiring cables, everything was put in hardware level. So this is a picture of ENIAC. If you remember, or if you have seen computers like this in the early days, people directly work there. So changing wires, everything done by hand, right? Early days, there was a lot of ladies were involved in very early days. Right? So they are the ones actually, find out any errors in the program, right? You can see they were carrying some cables, right? So that's how they were interact with the hardware. So it was not like nowadays we have operating system like Windows, because when it comes to Windows and so on, it will automatically manage everything. But those days, everything human has to involve. Because users have to work with the hardware, they have to have a good understanding. So we say they have to have a sound understanding about the hardware things. So users should have sound knowledge. So users should have sound knowledge on hardware stuff, because they have to know what is happening. Sound knowledge on hardware. And the final point, when you want to run program, it's not like today, right? So you have to, use magnetic tapes or, punch cards, you have to use switches, printers, everything is involved. we can say, okay, program execution. That means when you want to run a program, required to prepare the equipment. Prepare the equipment. Right? So what do you mean by preparing? It could be a couple of things. Now it could be mounting magnetic tape, because when you want to save data, usually early days you were using, what we call magnetic tapes. So magnetic tape, something like this, right? Right. So magnetic tape, something like this is the tape where you have to put it into, in the machine. So mounting, that is, you have to set the tape and you have to place punch cards. So placing punch card means early days, you have to have like a set of, set of punch cards. You have to put bunch of punch cards in the machine, right? It was not like today, right? You have to put them into the machine, right? So let me show you another image. So in this this image, what you see here is like you are putting a punch card in a machine, right? Now here, this is the punch card and this is the computer. So you have to put a, bunch of, it's not a single punch card, bunch of punch cards, one punch card per instruction. So you have to use. Okay. And there are other things, right? You have to set switches. You can see here in the machine, there are some switches there. You have to set. And printers. Right. පුතා මේ කොටස ලියාගෙන උනහම කියන්න අපි ඊළඟ එකට යමු. පළවෙනි එක ගැන ඔච්චරයි අපි කතා කරන්න ඕන. Right. Let's move to the second one. Now, the second one is batch processing systems. So the second one is we call simple batch processing systems, where you work on right, we'll write down. So under this one, during 1955 to 1965, right? Batch operating systems were used. Batch processing systems were used, right? So that means during that time, the operating system, there was operating system, but it's a batch operating system. Right? There was no direct access. To the machine, right? Direct access means early days, programs directly involved with the hardware. Now, by that 1955 to 65, there's no direct access. A group of jobs we call batch. That's what we call batch. Right? Were placed on the input device. So during 1955 to 65, batch processing systems were used. So that means there was operating system, but those times, a group of jobs, batch, we were putting inside the computer. Right. Let's look at some characteristics. So here are the things, the data, programs were stored in magnetic tapes. Right? So the programs we stored in, magnetic tapes, we have seen the magnetic tape earlier, and they were execute one at a time. Operating system loaded and executed programs one at a time. That's what we call batch processing, right? You take one at a time. When the current program ended the execution, the output written into another tape and OS load the next program. So the first point that you need to remember, all the programs we store in magnetic tapes, then operating system is loaded. It will take one program at a time and it will finish it. Then you get another program. Finally, the output tape was printed. Right? So that's what will happen during this. Processor is processor is in idle. Idle means without any work during input and output, right? So this is one of the issues. right. පුතා ලියාගෙන ඉවරනම කියන්න. Let's move to the multi-program batch system. So this is the third generation. So in the third generation, the issue was in the second generation, the processor was in idle state. Idle කියලා කියන්නේ there was no work. So when you input and the input කියලා කියන්නේ you are getting input from the tape, and the output means you are taking printout. So during those times, processor was in idle situation. So there was no work. So in multi-program batch system, they are trying to minimize this, right? So what they did, they actually divide the memory. So in the memory, they were holding multiple programs, right? So that's how they have handled. So in early case, they will take one program at a time. So here they are taking multiple programs, and you are putting into different places in the memory, right? So it will take one program, and then other programs are in the memory, right? When program is actually running, others are memory. So what happens? Processor will be always busy, because like even the one program finishes, the other one is in the processor. So that's what we call multi-program batch system, right? Right. Let's write down about this one. So this happens during 1965 to 1980, right? I told you like the third generation. Okay. The operating system could perform multiple jobs or tasks, right? At a time. We can say OS could, process, we'll say process, process multiple jobs at a time. So we can use characteristics. So the characteristics were, we can say one job, right? One job could be in the processor while other jobs busy with input output. And the second one is memory.
Mama screen like a stuck.
Then hari put
Harim.
right. So this is during 1965, right? So this is during 1965 to 1980. Right. පුතාලා ලියලි වරුණා මට කියන්න. Right. Let's move to the next one. Right. The next topic is time sharing. Right. So after 1980, we have time sharing systems. Right. So the time sharing systems are used during 1980 to nowadays. What we have is time sharing. So what do you mean by time sharing? Right. We use multi-programming to handle multiple jobs, right? And then the processor is handled or shared with multiple people. And with that, multiple users can access the system simultaneously. So early days, it was like maybe one job. Huh? So that's all what we have. But now you can have multiple programs. Right. So let's write down. Right. In time sharing system, that means 1980 to present day time sharing. It says minimum response time. Response means when you execute a job, you get a results. That time it takes is very minimal. And user interaction is also maximized. So basically, we will use processor time, and that processor time can be shared among multiple users. So that's why we call it as a time sharing system. පුතාලි ලියවුන නම් මට කියන්න. So one of the advantages is time sharing is multiple users can access. So earlier we will discuss about a single user, but multiple tasks. So right. Okay. Let's move to the next one then. So now we are going to look at a new topic. We are going to look at what are the main functions of operating system. Now you know, now operating systems, manage multiple things. They manage processors, they manage memory, they manage different devices, they manage files, security, and even it, provide you the interface. So let's write down the next part, that is main functions of operating system, right? Main functions of operating system. So it's a new topic. Right? Let's write down main functions of operating system. So operating systems helps us in managing multiple things. So let's write down those multiple things first, right? So it does manage processors, it manage memory, it manage devices, it manage files, it manage security, and also it provides an interface. Message එකක් දාන්න පුතේ ඔයාලා ලියලා ඉවර නම්. So the main functions of operating system, first one, process management, memory management, device management, file management, security management, and it will also provide you the interface. So nowadays we have graphical user interfaces, but early days we had command line operating systems. Right. Let's start with the process management first. So let's see what process management is. Now, process means when you use any, if you run any job, it could be a word processor, it could be, listening to a song or playing a game, it will create processors. So now it could be more than one processor. Like when you run a program, it might generate multiple processors. So let's see how operating systems manages, right, the processors. So process management. Right. Now, few things we need to note. Now, when you're running a software, like I said, so in process management, I will give you time to take down. Now, when you want to run a software, what will happen? It usually create multiple processes. So if you look at a process, it is a set of instructions, right? And when you take a particular point in time, you can have only one processor inside the CPU. So which means during the process management, you have to, choose a way to, execute each processor. So there will be a selected order of, processors, and you need to share files, memory, input, output, and CPU. So everything needs to be controlled during the process management. Let's take down. පුතල් ලිලි වුණාම මට මැසේජ් එකක් දාන්න. right. Okay. එහෙනම් මතක තියාගන්න ඕන දේ තමයි process management වලදී සාමාන්‍ය software run වෙනකොට processes කීපයක් හැදෙනවා. process එකක් කියන්නේ අපි instructions කීපයක්. හැබැයි එක සැරයක් ගත්තාම එක process එකක් විතරයි වැඩ කරන්නේ CPU එකේ. ඒක නිසා අනෙක් processes right activate වෙන්නේ one at a time. හරි? එතකොට සමහර ඒවා share කරන්න වෙනවා. file share කරන්න වෙනවා, memory share කරන්න වෙනවා. input output devices share කරන්න වෙනවා. CPU share කරන්න වෙනවා. So that is what we call process management. Right. Now let's move to the memory management. Right. The second one that I want to discuss is right memory management. Right. So we are going to look at memory management now. Let's write down the topic memory management. Now, when I say multiple processors, right, we have to divide the memory into several parts, right? We have to divide the memory. And remember, when you're dividing, there should not be any issues. We call without any collision. And finally, once the task is finished, the job is done, operating system should release the memory. Release means the refresh the memory, right? So that is what we need to discuss. So when we say when multiple tasks are executed, memory should be allocated to each task without any collision. So there should not be any issues when you're running multiple tasks. And input instruction and data to CPU and output information from CPU are kept in the memory. When a task is completed, OS should release memory for another task. Right, let's write down. Right. Memory management එක ලියලා ඉවරද පුතේ? තව වෙලා වොන්ද? Right, good. So let's move to the next one. Now, memories also should be managed, and operating system does that. The next one is we call device management. There are a lot of devices are connected to the computer, right? Sometimes we call peripheral devices, right? So when the devices are connected, right? That means the keyboard, the mouse, monitor, printer, scan, and so on, right? We have to look for, right? Now handling this. And then when you work with devices, you have to have a special software to, work with the device. Now, for example, when you take a printer, so in printer, to work with the printer, first of all, you have to install some software to communicate with the printer. Usually we use the term device driver, right? And in some cases, you don't have to, any special software such. You can plug and you can work with the device. And this is known as plug and play devices, right? Okay, so let's write down device management. Deliverලා පුතා මට පණිවිඩයක් තියන්න ඊළඟ එකට යන්න. Right. Let's write down more on device management. Now, what we discussed so far is whenever you work with multiple devices, right? We have to, handle these different devices. Now, for example, when you want to make a printout, you have to make sure that the printer is ready, right? You have to check all these. And, these devices, you have different speeds, right? Speed matters because if you're getting a data quickly, then you don't know how to handle it, right? So similar thing happens here as well. But you need a special piece of software, right? And then nowadays, you don't have to do this. You can just connect and work. We call plug and play devices. So here are some of the tasks done by the operating system. Right. So during the device management, it uses what we call the device drivers, the software that needs to work with the other machines. And you can control, you can communicate, monitor with device drivers. Okay. Right. Let's move to the next one. Right. It's called file management. The next one we are going to talk about file management. So what do you do during file management? Okay. Now, file management, you can do a lot of things, like you can create files, directories, you can provide access. Access means sometimes you can allow users to change the program, you can run the program and so on. And during the file management, it will allocate various parts, and these are for files. Right. So let's write down those tasks. Right. Here are the things that we can write down. The file management task include create and delete both files and directories, provide access to files, allocate space for files, keep backup of files, and finally secure our files. Right. When you finish writing down, please let me know. පුතාලා මේක යටට කියලා ඉදිවට නම් මට මැසේජ් එකක් දාන්න. Right. Okay. The next one we are going to discuss is security management. Now, security means like we have to make sure the files that we create, right? Now, for example, not all the users are allowed to, write programs. We can restrict this. And sometimes you are asked to provide your username and password. So that is to say that, okay, right? For the security purpose, we are checking that. And you can also use firewalls, like in firewalls, you can limit the connections coming from the outside, right? Okay, let's write down this. So what we have been discussing is security management. So security management. So what it does during, security management, you have to protect as operating system. You have to protect the whole system, not a part of it. Right. And the authentication means once you log into the system, it will determine whether you can read, write, or encrypt the data. Second part, using authentication means providing username and password to the secure system. From unauthorized users, firewalls are used to restrict access to the system by users outside the network. In data transmission, data is encrypted such a way that data could be read by the authorized details only. Right. So let's take down this, and then once you finish, please let me know by raising your hands.